Audiobook Academy Biography presents Isaac Newton. Scientist and mathematician Isaac Newton is well known for the principles of physics he devised. During the 17th century, he played a significant role in the scientific revolution. Isaac Newton, who was he? Isaac Newton was a scientist and mathematician best known for developing the laws of motion and other foundational concepts in modern physics. He is considered a key figure in the scientific revolution of the 17th century. The Philosophiae Naturalis Principia Mathematica, Physical Principles of Natural Philosophy, his most celebrated work, was published in 1687 and has been named the most significant book on physics ever written. Queen Anne of England knighted him in 1705, elevating him to the title of Sir Isaac Newton. Early years and family. England's Woolsthorpe was the place of birth for Sir Isaac Newton on January 4, 1643. Newton was born on December 25, 1642. According to the Julian calendar. Isaac Newton, his wealthy father, died 3 months before Newton was born, leaving him the sole heir to the family land. Newton was born prematurely, and he was expected to die. A well-to-do pastor named Barnabas Smith, who was married to Newton's mother, Hannah Askew Newton, took care of the young boy when he was 3 years old. Later, Newton had an extreme sense of insecurity as a result of the encounter. Anxiously and irrationally defended the quality of his published work. After the death of his mother's second husband, Newton, then 12, was reunited with his mother. She brought her second husband's 3 young children with her. Education. At King's School in Grantham, a small town in Lincolnshire, Newton was given the opportunity to learn about the exciting realm of chemistry from the local pharmacist. At the age of 12, his mother forcibly removed him from school. She intended to turn him into a farmer and assign him to take care of the property. Newton was a flop at farming because he disliked the monotony of it. After a short time, Newton was sent back to King's School to conclude his elementary education. Newton's mother was encouraged to send her son to Cambridge University by his uncle, a graduate of Trinity College, who may have sensed the young man's innate genius. In 1661, Newton joined in a work-study program comparable to a college internship, where he worked as a waiter and housekeeper for wealthy pupils. Revolution in scientific knowledge. During the scientific revolution of the 17th century, Newton came to Cambridge. All of Europe's academics were familiar with the heliocentric concept of the universe, developed by astronomers Nicholas Copernicus and Johannes Kepler and improved by Galileo. Reformed philosopher René Descartes had begun to think of nature as an elaborate, impersonal and inactive mechanism. In contrast, Cambridge, like most European universities, was immersed in Aristotelian philosophy and a geocentric understanding of the universe, dealing with nature in qualitative rather than quantitative ways. At Cambridge, Newton was given a basic education, but he was fascinated by more advanced science throughout his first 3 years. He spent all of his free time reading contemporary thinkers. In light of the fact that he was enrolled in a dual degree program, the outcome seemed understandable. Newton kept a second set of notes, named Quaestiones Quaedam Philosophicae. Throughout this time period, certain philosophical questions discovered by Newton in the Quaestiones was the new understanding of nature that laid the foundation for scientific advancement. Despite the fact that Newton did not receive any awards or distinctions, he was named a scholar and received 4 years of financial aid for his future schooling. The bubonic plague that was destroying Europe had reached Cambridge in 1665, forcing the university to shut down. A minor fellow at Trinity College, Newton's own mater, welcomed him back to Cambridge in 1667 after an absence of 2 years. After a few more years, he had a better financial situation. Prior to the year 1669, Newton got a Master of Arts degree in mathematics from the University of Cambridge. His search for ways to deal with infinite series led him to come upon an older publication by Nicholas Mercator at this time period. In a short period of time, Newton penned a book titled De Analysi in which he elaborated on his own discoveries. However, he did not put his identity as the author when he shared this with Isaac Barrow, a friend and mentor. British mathematician John Collins received the uncredited paper from Barrow in June 1669. Mr. Newton. Quite young, but of an astonishing genius and proficiency in these things, Barrow told Collins in August 1669 of the book's author, who had just turned 18. Mathematicians had never heard of Newton's work until this event occurred. The next year, Barrow resigned from his Lucasian professorship at Cambridge to make way for Newton as the new occupant of the post. The discoveries of Sir Isaac Newton. Discoveries in optics, movement and mathematics were accomplished by Newton. All hues of the spectrum might be combined to produce white light, according to Newton's theory. Principia, his seminal work on physics, contains information on nearly all of the field's fundamental principles, with the exception of energy, and ultimately assisted him in explaining the laws of motion and gravity theory. Newton, along with Gottfried Wilhelm von Leibniz, is often regarded as one of the founders of calculus theory. Inventions by Isaac Newton. In 1668, Newton designed and built a reflecting telescope, his first major public scientific achievement. Newton had to give a series of lectures every year as part of his duties as a professor at Cambridge, and optics was the first subject he chose to tackle. Astronomy helped him prove his theory of light and color through the use of a telescope. For his 1672 publication of his Notes on Light, Optics, and Color as a result of the Royal Society's interest, Newton gave a demonstration of his reflecting telescope to the organization that year, 1671. According to Newton, these observations were later published as part of his Optics, or, a treatise of the reflections. Myth of the Apple. Newton came home from Trinity College between 1665 and 1667 to pursue independent study because of the Great Plague. Newton is said to have been inspired by the falling apple at this exact moment, according to legend. Many people believe that Newton came up with the theory of gravity one day while sitting under an apple tree and having a fruit fall on his head. Newton saw an apple fall from a tree, leading him to wonder why it came straight down and not at an angle. Despite this, there is no evidence that the apple actually hit Newton on the head. As a result, he began to investigate motion and gravity ideas. At the age of 18, Newton took an 18-month break from his studies, during which time he came up with a slew of groundbreaking ideas that would go on to influence everything from his theory of infinitesimal calculus to his theories of light and color. Laws of Motion by Isaac Newton. Newton published Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, in 1687, after 18 months of hard and nearly non-stop study. The most influential book in physics, if not all of science, is considered to be Principia. Newton became a household name around the world after its release. Principia presents a precise quantitative account of entities in motion with three fundamental but crucial rules of movement. First law. A stationary body will stay stationary unless an external force is applied to it. Second law. Force is equal to mass times acceleration, and a change in motion, i.e., change in speed, is proportional to the force applied. Third law. For every action, there is an equal and opposite reaction. Newton's gravitational theory. Newton's Principia outlined the three fundamental rules of motion that he used to develop his theory of gravity. When two objects are in close proximity, they are attracted to one another by a gravitational force that is directly related to the mass of the closer object and inversely proportionate to their distance from the farther object. Elliptical planetary orbits, as well as the motion of the Moon, Jupiter's moons, and comets on elliptical paths around the Sun were all made clear by these principles, which also explained the motion of practically every other object in the cosmos. Using these tools he was also able to compute the mass of each planet, as well as determining how the Earth's tides are created by the gravitational pull of Sun and Moon. Newton believed that gravity was the key to keeping the universe in balance, making it operate, and bringing heaven and earth together in a grand equation. Robert Hooke and Isaac Newton. Nobody in the Royal Academy was thrilled about Newton's optics discoveries and the publication in 1672 of Optic, or a treatise of the reflections, inflections and colors of light findings. Robert Hooke, an excellent scientist in a variety of fields including mechanics and optics and a founding member of the Royal Academy, was one of the dissidents. Newton believed that light was formed of particles, whereas Hooke held that it was composed of wavelets. Newton's study was swiftly panned by Hooke, who criticized Newton's approach as well as his conclusions. There were others who questioned Newton's optics work, such as Hooke and Galileo. Many French Jesuits and well-known Dutch scientists, like Christian Huygens, voiced their disapproval. However, Newton was the most hurt by Hooke's criticisms due to his close involvement with the Royal Society and his own work in optics. He erupted into a rage because he couldn't handle the criticism, a reaction that would continue throughout his life. Newton rejected Hooke's claim that his theories had any flaws and maintained that his findings were critical to the advancement of science as a whole. In the months that followed, the debate between Newton and Boyle became increasingly heated, and Newton even threatened to resign from the Royal Society as a result. He stayed only because he was persuaded that the fellows held him in great regard by several other members. It would be a long time before Newton and Hooke could put their differences behind them. The correspondence unexpectedly came to a stop when Newton suffered a nervous collapse in 1678. After his mother died the next year, he became even more secluded, and for the next 6 years, he only spoke with people via brief letters that they initiated. Newton returned to his research on gravitation and the effects it has on planets' orbits after taking a break from public life. Robert Hooke was the person who gave Newton the push he needed in this study. During a communication with Newton in 1679, Hooke brought up the subject of planetary motion, claiming that an inverse squares formula may explain the gravitational pull of planets and the shapes of their elliptical orbits. Prior to Newton's abrupt cessation of communication, there were a few more interactions. However, Newton's study on planetary motion swiftly absorbed Hooke's notion, and from his notes it appears he had made his own conclusions by 1680, albeit he kept his findings to himself. He stated his case for planet motion in 1684 in a discussion with Royal Society members Christopher Wren and Edmund Halley. Wren and Halley agreed that he had a point, but they both insisted that he provide a mathematical demonstration to back up his claim. Halley visited Newton in Cambridge in August 1684, when he was emerging from seclusion. According to Hooke's theory, what shape would a planet's orbit assume if it was attracted to the Sun in an inverse square fashion? Because he had been working on it for the last 6 years, Newton knew the answer and responded, an ellipse. It had been 18 years since Newton had left Cambridge due to the plague and claimed to have solved the problem, but he couldn't find his notes. Newton was convinced to work out the problem mathematically by Halley, who offered to pay all the expenditures so that Newton's Principia could publish the ideas, which it did. Robert Hooke quickly accused Newton of plagiarism once the first edition of Principia was published in 1687, saying that he had discovered the inverse squares theory and that Newton had stolen his work. Because Hooke had merely hypothesized about the theory and never demonstrated it, the accusation was false, as the majority of scientists were aware. Despite this, Newton was enraged and defended his discoveries vigorously. He deleted all references to Hooke from his notebooks and threatened to withdraw from publishing the next edition of Principia. When Halley learned of Newton's betrayal, he made an effort to mend fences between the two scientists. In spite of Newton's reluctance to acknowledge Hooke's work in his exposition of the law of inverse squares, it did not pacify Hooke in any way. Hooke's life began to fall apart as time passed. In 1687, the same year that Principia was published, he lost his beloved niece and companion. By contrast, Newton's name and prestige soared, and Hooke's diminished, making him more enraged and despised of his opponent. Hooke continued to find ways to berate Newton to the very end. Hooke refused to step down until the year of his death in 1703, knowing that his competitor was about to be elected president of the Royal Society. Alchemy and Newton. Newton was eager to begin a new chapter in his life with the publication of Principia. He was no longer happy in his job at Cambridge, and he was getting more active in other causes as a result of that. He was elected to represent Cambridge in Parliament in 1689 after leading the opposition to King James II's attempts to reinstitute Catholic teaching at Cambridge. After arriving in London, Newton became acquainted with the political philosopher John Locke and a wider circle of thinkers. In contrast to many European scientists, a new generation of British scientists was enthralled by Newton's new understanding of the physical universe and saw him as their leader. Newton made friends with a Swiss mathematician named Nicolas Fosio de Duillier while he was in London. Newton, on the other hand, suffered another nervous breakdown in 1693, only a few years later. Any number of factors could be to blame, including dissatisfaction over not being given a promotion by William III and Mary II, or deterioration in their relationship due to their mutual dislike for Duillier, as well as exhaustion brought on by their long careers in alchemy. Many of Newton's London contacts and associates, including Duillier, whom he wrote letters to accusing them of betrayal, appear to have been influenced by Newton's paranoid and delusional writings. Interestingly, Newton recovered fast, wrote letters of apologies to friends, and was back to work within a few months of his ordeal being done with. However, he appeared to have lost interest in scientific issues and instead concentrated on studying prophecy, scripture, and alchemy. Even though this can be seen as work beneath the man who had revolutionized science, it is more likely that Newton was reacting to events in volatile 17th-century Britain. Religion, politics, and the meaning of life were just a few of the topics on which many intellectuals were debating. Modern science was still in its infancy, and no one could say for sure how it compared to ancient beliefs. Gold standard. As a result of his new post as Warden of the Mint, Newton permanently relocated to London, where he resided with his niece, Catherine Barton, until his death. Her relationship with Lord Halifax, a high-ranking member of Parliament, was essential in getting Newton appointed Master of the Mint, an office he would maintain until his death at the age of 66 in 1704. For Newton, the job wasn't just an honorary one, therefore he took it seriously, changing the money and imposing harsh penalties on counterfeiters. Newton served as the Master of the Mint, and he was responsible for moving the British pound sterling from the silver standard to the gold one. The Royal Society. After Robert Hooke's death in 1703, Newton was elected as the new president of the Royal Society. Newton, on the other hand, never appeared to grasp the concept of science as a team effort, and his zeal for his own discoveries and steadfast defense of them led him into fight after battle with other scientists. A tyrant and despot, Newton ruled over the society with an iron fist. He had complete authority over the lives and careers of society's younger members. Several years before Newton's publication of the Principia, the German mathematician Gottfried Leibniz openly accused Newton of plagiarizing his research, saying that he had developed infinitesimal calculus several years earlier. An investigation committee was formed by the Royal Society in 1712 to examine the issue. So of course Newton could appoint and supervise committee members, as he was president of a scientific institution. The committee, not unexpectedly, ranked Newton above the discoverer. In the same year, in yet another display of Newton's tyranny, he published without permission the notes of astronomer John Flamsteed, who was working on a companion paper to his own. It appears that the astronomer had amassed a substantial amount of data during his time at the Royal Observatory in Greenwich, England. In order to revise Principia, Newton requested a substantial amount of Flamsteed's notes. Newton used his position as president of the Royal Society to get Flamsteed to furnish him with more information more rapidly. Flamsteed's star catalogue, as well as all of Flamsteed's notes, edited and uncut, were then forced into print by him. To make matters worse, Newton had Edmund Halley, Flamsteed's sworn opponent, prepare the notes for publication. Finally, Flamsteed won his battle against Newton in the courts, which was one of the few times that Newton was beaten by one of his opponents. Last years. Newton resided with his niece, Catherine Barton Conduit, and her husband, John Conduit, at Cranberry Park, near Winchester, England, near the end of his life. Newton had risen to prominence in Europe by this point. His discoveries in science were uncontested. He, too, had made a fortune by prudently investing his money and giving generously to charity. Contrary to public perceptions, Newton's life wasn't perfect. He was single for most of his adulthood without ever getting married or having many close friends. His friends were even concerned about his mental health in his later years when he was consumed with pride, insecurity, and a rash of eccentric scientific inquiries. Death. As he approached his 80th birthday, Newton began to suffer from digestive issues and had to radically alter his diet and exercise routine. Newton lost consciousness in March of 1727 after suffering from severe abdominal pain. On March 31, 1727, at the age of 84, he died. Legacy. After his death, several of Newton's contemporaries went on record as calling him the greatest genius of all time. However, he had a profound impact on Western thought that led to parallels to Plato and Aristotle and Galileo, to name a few. Newton's universal principles of gravity found no analogies in science at the time of his discoveries, which were made during the scientific revolution. Some of Newton's key assumptions have been disproved. In the 20th century, Albert Einstein would challenge Newton's view of the cosmos, arguing that time, space, and motion were all relative, and that the universe was far more amazing than Newton had imagined. Newton might not have been surprised, in his later in life, when asked for an evaluation of his accomplishments, he responded, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself now and then in finding a smoother pebble or prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Thank you for listening in Audiobook Academy. Don't forget to subscribe and smash that like button for more content like this. See you in next video.